So last time we looked at the sum and average and minimum and maximum of these two data sets. And what's interesting is that the average is the same for both. It's 3, even though these data sets are quite a bit different. And you can see when you look at the minimum and the maximum that there's a larger range for the buildings with the safe glass that's supposed to reduce bird collisions than the range on the non-safe glass buildings with regular glass. So if you just reported the average and just said it's the same, that really wouldn't be an accurate representation or a full representation of the data. So this is why we always want to report measures of central tendency like average, and also measures of dispersion like the range. But the range itself is limited in its ability to tell us much about the data because it's just the very lowest value and the very highest value. And you can imagine if you had a much larger data set and just happen to have a very low or a very high data value, that the range would look really enormous even if most values are closer to the mean. So this is where a term known as standard deviation becomes useful. This is a calculation that will sort of tell us the average spread outedness. That's not really a word, but spread outedness of the data. And so it's going to teach us how typical the values are around the mean. The way we calculate it is using this formula. And please don't be overwhelmed by this formula. S here stands for standard deviation. Then if you look at the other variables in this or parameters in this formula, you'll see that the sum symbol, this always means sum up all the values. X sub I is each individual value in the data set. And then X with this line atop is in math is used to denote the average. You're going to square those values and sum them and then divide by the sample size minus 1. And I'll explain why we do that as we go through it. So let's take the non-safe glass building data set and we will just copy that. So Control C if you're on a PC. I believe it'll be Command C if you're on a Mac. And you copy in that data set. So each of these is the X sub I's. The mean of this data set is the average is 3. So we can just put 3 in for all of those. Then if we look at this formula, we're going to take each of the values and subtract the mean. So we'll go here and type equal, and we'll take the X sub I value and minus the average. So that's going to be 0, right? There was no deviation from the mean for that data point because it was the same as the mean. We can drag this down and we'll see that one value in this data set was higher than the mean and one was lower than the mean. Now, if we summed this all up without squaring it, it would add up to 0. And so that's because there's always going to be values above and below the mean, and it's going to be equivalent in a data set. So that's why we're going to square it. So we hit equals, and then I hit shift and 6. Actually, I hit the data point first, and then shift and 6, which gives me this little symbol, which is to square that value. And I can drag that down. So now I've squared 1 and I have 1. I've squared -1 and I have 1 as well. Now I can hit sum this data because that's what our formula is asking to do, is sum all the values. It's 2. And now we're going to divide by n minus 1. So since there were 4 of these values, and minus 1 is 3. So we'll take this and go equals 2 divided by 3. And that's 0.666. And if we take the square root of that, we should then have standard deviation. So to get square root, you start to type SQ. And you will see it auto-populates the square root of a positive number. So I'm going to click that. I'm going to click this value and close it off and hit enter. So this is the standard deviation. It is the standard or typical deviation of each of these data points from the mean. And if you don't believe me, there's an easier way you could do all this, which is just type equals and start to write standard deviation. You'll see an option here for STDEV, standard deviation. Highlight the data set, close out the parentheses, and hit enter. And look at that, 0.816. That's the same. You can actually go here and increase the number of significant digits and see that it's exactly the same as when we calculate it using the actual formula. So I want to demonstrate that so that you could see how these formulas work. And look at this, when I drag it over and I'm looking at the standard deviation of the safe glass buildings, it's much higher. There's more variation on average around the mean in this data set because there's a larger range and more values deviate than this one where most values are closer to the mean. So that's what we would expect. Standard deviation, a super important and useful way of summarizing your data.